All right, so this page is going to go quite fast. Now these are all on your formula sheet, but let's just write them out. The derivative of sine u is cos u du over dx. Oops. So you want to make sure that you're always doing the derivative of u after you're finished. The next one is negative sine u du over dx. Now tan u, which is a new one, would be its secant squared u du over dx. Okay, now this one, cosecant u, is negative cosecant u cotan u du over dx. And secant u is secant u tan u du over dx. Okay, and then cotan u is negative cosecant squared u du over dx. Okay, so again, the big difference between this year and when you take it in calculus next year is you won't have the formula sheet. You just have to memorize these. And that's probably the hardest thing of the second calculus course you take. There's just pages of stuff to memorize. So you kind of really have to commit the time to learning all of these, which of course isn't fun. And you forget it, you know, a couple days after you write the test anyway. But you don't get formula sheets, so that's just the way it goes. Okay, so you can either have your formula sheet out, or you can see obviously the top of the page. You can be looking at it. But these are all on your formula sheet. So if we had 3 tan 2x, so the 3 is going to stay there. So dy over dx would equal 3. And then tan u is secant squared. U is 2x. And then du over dx would be times 2. So dy over dx, or y prime, would be 6 secant squared 2x. Okay? So, y prime for this one, number 2, is the 12 will stay there, and that's secant u is the derivative of secant u tan u, right? So that would be secant 1/4 x tan 1/4 x. And then we have to do the derivative of the u, which is 1/4. Okay, the 1/4 and the 12 will get together. That's 12 over 4. So we'll get 3 secant. Now, 1/4 x, or x over 4, I'm just going to write it that way so you get kind of used to, of course, if you left it as 1/4 x, it would not be wrong. But there is an invisible one still up there. Okay, so this one, again, maybe this helps you better. It does for me. Tan cos x, and that's all squared. Okay, so remember we do the derivative from the outside in. So y prime would equal, I've got 2 tan cos x. Now theoretically I don't need those brackets there anymore, but I wanted to show that I was doing first the outside. Now I'm going to do the derivative of the inside of those brackets, which is secant squared cos x. Okay, so this is kind of weird because there's a trig function within a trig function, but I'm still going to go, I'm going to do the derivative, and then the derivative of cos x, negative sin x. So probably the only thing to simplify this would be negative 2 tan cos x secant squared cos x times sin x. All I did was bring that negative in the front. Okay, now number 4, if you want to escape the quotient rule and just use the chain rule, make this secant bracket secant 2x minus 1 to the negative 3 over 2. Okay, so then it's kind of similar to number 3. We'll bring, so y prime, we'll get negative 3 over 2 out front, secant 2x minus 1. Okay, and if I'm going to, it means I got a minus 2 over 2 over it, so that'll be minus 5 over 2. Okay, now the derivative of the inside would be secant 2x minus 1 tan 2x minus 1. And then I've got to do du over dx, and that's times 2. Okay, now there is one thing we can do here. Do you see that we have a secant 2x minus 1 to the negative 5, and we've got this one to the 1, right? So those are like terms. It's like having a g to the 4, g to the 5. That would be g to the 9, right? So we want to add those two together, and that would get this, that's 2 over 2, right? So when you add those two together, you'll get, and this 2 over here, this 2 cancels with that 2. So I will get negative 3, then secant 2x minus 1. And I'm going to add those two together, so I will get negative 3 over 2. And then I've got tan 2x minus 1. Okay, so I didn't factor out, I just combined. Okay, Matt, inside voice. Okay, and then the last thing you want to do is just make the exponent. So I got negative 3 tan 2x minus 1. And on the bottom, I'll put secant 2x minus 1 to the 3 over 2. And you could also do the square root. I'll just write this so you're... Okay, it also means that, right? Okay, so you want to get out that sheet that you picked up has two supplemental questions that is review as well as dealing with the new trig derivatives you just learned. Okay, so it says find the equation of the tangent line of this equation at pi over 6. So you've got a curve, a sinusoidal function going here, and at any point we can find the slope of it, right? So we want to find, well, what would be the equation of the line at that? We've done lots of these, but we haven't done any on we've done them on graphs that weren't trig functions, and now we're going to do a trig graph. Okay, so the first thing we need to do when you want to find the equation of a line is you need slope. And just like always, when you take the derivative of your graph, you can get the slope at any point given that point, and they've given us pi over 6. So y prime would equal cosecant x is negative cotan x cosecant x minus 2, and sine x is cos x. So the slope at pi over 6. Well, again, we want to make sure we know that pi over 6 right here, this is root 3 over 2, comma 1/2. And tan here is root 3 over 3. So this is cos, that's sine, and that's tan. Now we can also do secant, would be 2 over root 3. Cosecant would be 2 over 1. And cotan would be 3 over root 3. And secant, I actually don't need for my formula, but I do need cosecant and I do need cotan. So I'm going to multiply this by root 3 over root 3. So this answer is root 3. Okay, because we don't want to have a radical in the bottom. So then it's just a matter of plugging stuff in. So y prime, or slope, would be negative. Now cotan x is root 3. Just look on the side there. Cosecant x is 2 minus 2 times cos x. Cos x is root 3 over 2. So y prime equals, this is negative 2 root 3 minus root 3, which equals negative 3 root 3. So this is my slope at pi over 6. Now, if you remember our equation, it's y minus y1 equals m, which is slope, x minus x1. We know x. We know my slope. I don't know y1, okay? But we can figure out y1 by our main equation. So this was the slope. 2, we need y at pi over 6. Okay, so then y equals cosecant pi over 6 minus 2 sine pi over 6. And we can still use the same graph that I drew already. Cosecant pi over 6 is 2. Minus 2 times sine pi over 6 is 1/2. So that's 2 minus 1. That is 1. So now I have my slope. I have my x, and I have my y. So 3 is the equation of line. So y minus 1 equals, slope is negative root 3, or negative 3 root 3 times x minus pi over 6. So y minus 1 equals negative 3 root 3x, and the negative 3 and the 6, that'll give me plus pi root 3 over 2. Just multiply this to this, right? The 3 and the 6. And I got a plus sign because a negative times a negative. Okay, one thing, we don't want any fractions, so let's multiply everybody by 2. So that will give me 2y minus 2 equals negative 6 root 3x plus pi root 3. Okay, so let's put everything on the left side. So I would have 6 root 3x plus 2y minus 2 minus pi root 3 equals 0. The minus 2 I just kept there. That's supposed to be a y. Okay, so actually, except for the fact that you got to know your unit circle to do this one, it's pretty well the same thing. You got your equation, find your slope, find your other point, just like we've always done. Okay, so this one is a review of the last unit using this stuff here. And pretty nice equation as far as having to do derivatives and stuff like that. Now it says find the max and min points, concavity, and the points of inflection. Okay, so we're going to have to do first derivative to find max and min points, and we'll have to do our second derivative for our concavity and points of inflection. Okay, so let's find the max and mins. Let's do first derivative. First derivative would equal sine is cos. So we got negative cos 2x, and then times du over dx is times 2. So this equals negative 2 cos 2x. Now the way we find max and mins, what have we always done? Yeah, how do you find them? Set it to 0. Okay, so then I divide by negative 2, and I get 0 equals cos 2x. Now, this is back to the objective we did a couple days ago, where this is cos 2x, not cos x, right? So there is a horizontal stretch of a half done here. So let's find when cos x equals 0. Okay, so this is a good review of this. So cos x equals 0 at pi over 2 and 3 pi over 2. Okay, so cos x equals 0 at pi over 2 and 3 pi over 2. Okay? Now if cos x has two answers, if cos x has two answers, cos 2x would have 4. Okay? So cos 2x, we want to say would have 4 answers. 1, 2, 3, 4. Now how do we find the first answer? Multiply by the 1/2. Where'd 1/2 come from? Good. Okay. So we've got a horizontal stretch by 1/2. So then I will get pi over 4 and 3 pi over 4 for my first two. How do I find the other two? Right. So actually 2 pi over b gives you the period, which would be 2 pi over 2, which would be pi. That's my period. Okay, so we're going to add 4 pi over 4 to this one. It's got to be a common denominator. So we'll get 5 pi over 4. And I'm going to add 4 pi over 4 to this one. So this is 7 pi over 4. So you have lots of room to keep working. You just flip on the back. If you're running out of room, you have the whole back to keep going with this. Now, this is where we want to test, because to find max and mins, remember, we have to put every single of our critical values on our line. Be very aware that we are not given over an entire domain. We are given between 0 and 2 pi. So we do have 0 here, and we've got 2 pi over here. So let's get these down. We got pi over 4. We got 3 pi over 4. I got 5 pi over 4. And 7 pi over 4. Now where these get to be a little bit more interesting is finding test values. Okay? So what I find works the best is I find the decimal for each one of them. Okay? And so what's pi over 4? What is that in decimal? 0.79. So I elected to use 0.7 on this side and 0.8 on this side. Because like you just said, this is 0.79. So, and remember that we want to put it into our derivative, negative 2 cos 2x. Okay, so we're going to put these numbers into here to test them. Okay, so I just want everybody to try the first one. Now make sure you're in radian mode. Yes? Yep. Yeah. Yep. Yeah, some people struggle with that. That's why that, but yeah, you could go 2 pi over 4, because they're all over 4s, which is nice too. Sometimes some will be over 6s, some will be over 3s, and then it's harder, right? But this one's nice. Yeah, you could have done. But then which one would you have picked? 0.5 over 4 for the between 0 and pi over 4? Well, 0 is actually, might even be a critical value, because we have to do less than 0, because it's round brackets. So you do get a negative when you plug that in. No, you don't do second because you're actually putting the angle in. So you're just going to put negative 2 cos 2x. But everybody should try it because it may seem like a simple thing. But you want to make sure you are getting a negative there. And then, I'm not sure the actual answer. Someone yelled it out. And then you could just keep hitting, oh yeah. Do you guys, can you do second enter on yours to bring back the last? On the TIs, I think you can, because that really helps, and then you can just keep going along. So what's 0.8 give you? 0.8 gives you a negative? Try it again. Yeah, it should be, but I think you want to kind of confirm that for yourself. Yeah. Syntax error and negative are wrong. Are you putting negative cos 2 times 0.8? Yeah, negative 2 cos 2 times 0.8. Yeah, you're in degree mode. You're in radian mode for sure. Yeah. Yeah. That's a good thing to learn before the test thingy on Wednesday. Is to here.
Just click the degree button.
Yeah. Where's it? Oh yeah. So you got degree, and then you just go over to radians and hit enter. See, it's a good thing we had this little talk, right? So just hit the degree button. Now, can everybody try it? DRG. Yeah, we don't want DRG. We want RAD. Well, they kind of aren't. Okay, is everybody getting a positive now? So you got a positive. Okay, so we should be getting a positive there. I'm just going to wait, make sure everyone's getting a positive. Here, let me see that one, because this is actually a finance calculator, isn't it?
Yep, that's what you're going into. So, you know, 1 millimeter. Money.
There's your.
I think the trig you have to put second, and then there's a little trig thing on top there. The first time I actually used calculus, except for pre-calculus.
Dude, I love these things are just basic. Good thing you have that small. Where's the trig function?
Little kick calculator. Just bring it back. Got that on my fridge on the first day, or on the first day of the semester. I was like, calculator, I'll just grab it off my fridge.
Yeah, I'm not seeing it right now. See if you can find it. Okay.
Boys found it right away.
Yeah. Where'd you find it?
It's like the same. It's like the same. It's like second DR. Second.
Oh, okay. Okay, so you should have got positive, then negative, then positive, then negative. Okay? So going down, up, then down again, then up, then down. So once we get that, yep. Well, I didn't test on the other side. I assume it should go up again, though, because it's periodic function. Okay. So now we know that we've got a min here and here. So we got a min at pi over 4, comma something, and 5 pi over 4, comma. Okay, now you can plug that right into, so we want to plug into, and remember this, right? Y equals negative sine 2x. So if you just put pi over 4 into the original, what do you get? Is that just your go-to answer no matter what? It's good. Mine's always 12, actually, but 0's probably going to get you more. My 12 never works. You should get -1. Okay. And 5 pi over 4, since this is periodic, you should get -1 as well. Your max, you've got a max at 3 pi over 4, comma something, and 5 pi over 4, oops, 7 pi over 4. Okay. What are we getting? 1, yep. Okay, so again, you're going to plug that into, then you'll get that, right? Yeah, it's common sense is sometimes more obvious after, right? So now, next thing we're going to do is concavity. And IPs, okay? So, again, remember the whole point of this course is to make sure that there's really no surprises next year, right? So I want to do, so this is kind of why I put this in, is I want to make sure that if you see these next year, you can get them. Now remember, -2 cos 2x was our first derivative, so second derivative would be -2 cos x is negative sine 2x, and then times 2 again. So we've got the negative and the negative, and the 2 and the 2, so y prime should be 4 sine 2x. Okay, so we can find IPs, that's going to be at critical values. So let's go 0 equals 4 sine 2x. I can divide both sides by 4. So sine 2x. So when does sine equal 0? It happens at 0 and pi. And yeah, it doesn't actually, or 2 pi it doesn't allow for. So really, but I'm putting it there because that's my endpoints. So I do want to kind of know what's going on there. And when I'm figuring out in between anyway, that's going to help me with my concave up, concave down. Those will definitely not be inflection points because they're at my ends. Yeah, in this case we just do the pi. Now the reason why, well, let's see. So I did it over the whole domain. I want to see if it affects it if we didn't. Okay, so yeah, it should. Yeah, it's harder to think about these though if we're going to change the way we do them. So if I do it over the entire domain, when does sine x equal 0? So sine x equals 0 at 0 and pi, and I guess 2 pi if we want to put that there. So for sine 2x, if we have 3 answers there, we should have 6, 1, 2, 3, 4, 5, 6. So what would be the first one? 0. The second one? Pi over 2. Okay, and what will be my period? 2 pi over 2, which is pi. Yeah, 2 pi over 2. So if I add to this one, I will get pi. And if I add it again, I will get 2 pi. So I'm not even going to have to go figure out that last one because that's definitely out of my domain. And then this one, I will just add my 2 pi over 2, which should give me 3 pi over 2. Yep. Well, this is really what I want to look for on my line, right? Because their domain is less than 0, or greater than 0 and less than 2 pi. So if you really wanted to, I mean, we could do this one here, but it's out of my domain, so I wouldn't be checking it on my thing anyway, right? Those are my ends, though, that I really want to check, right? There, you could see that not only, they would be critical values if this would have been square brackets, right? Okay, so we got 0, we got pi over 2, we got pi, we got 3 pi over 2, and we've got 2 pi. Oh, this is y double prime. I guess I should just go up and label this y prime. Okay, so I used, for me, a number under was like 1.4. Maybe everybody should just try it and make sure they are getting what I'm getting. So remember, you were plugging this into your second derivative, right? 4 sine 2x. 0.7. So you get a positive. Okay, and positive is happy. Okay, and this one I tried 1.7. Just everybody try 1.7. Okay, and so I think people are, their calculators working for them. So this will give you a like this and like this. Okay, so we have inflection points at pi over 2, comma something, pi, comma something, and 3 pi over 2, comma something. And again, we're not going to check 0 and 2 pi. They're out of our domain. And make sure we're plugging this into negative sine 2x, not into anything else. Again, the answers kind of make sense. You are getting 0. So it wants, so anyway, it would be concave up, 0 comma pi over 2, union pi, 3 pi over 2, and concave down, pi over 2, comma pi, union 3 pi over 2, comma 2 pi. Okay, so this was doing, you will be doing this next year as well. It actually pays not to throw this stuff away because hopefully you're doing all the same stuff again and you have your old notes. But that's why I wanted you to have this, because you wouldn't have old notes. So that's why that's kind of a supplemental page, and then here's the work right there, right?